Hello and welcome to SudoKanard. Here's another puzzle that was featured in this round 3 of WPF Sudoku Grand Prix of 2022, organized by China and authored by Siyuan Luo. And this puzzle, as opposed as most of the ones I featured on the channel recently, is one that I did solve during the contest, and it took me quite a while. So it's called Anti-Windoku, and it's not to be mistaken with Windoku. In Windoku, you need to put all 9 digits in every shaded region, but the rule here is quite different. On the contrary, the 4 digits that are here are the only digits that you are allowed to place here. So there are only 4 different digits in such a shaded region. And that's it. So where do we start? Well, the interesting thing is that this 2 has to be somewhere here. And similarly, this 4 has to be somewhere. This 8 here. And this 6 here. And the counterpart is that such a digit as 9 and 5 here can't be in any of those cells, so they can't be in any of those cells either. And if you take this 9 and this 9 can't be in this region at all. This 9 can't be in this region at all. So in this box, 9 is ruled out of those cells and those cells by Sudoku, and ruled out of those 2 cells by the logic I just mentioned. So you've got a 9 here. So 9 will have to appear somewhere in one of those cells. Now looking at this region, 9 can't be here, 9 can't be here by Sudoku. It can't be here because of this 9, and it can't be here because then we would have to place it somewhere here. So 9 can only be here. 9 can only be here in this region, and this is compatible with this 9. And then, knowing that we can't have a 9 in this region, there's a 9 up there, and there has to be a 9 somewhere here. And something interesting here is that if 9 is here, then we can't put it in any of those 2 cells. And if 9 is here, then it's not here, so we can't put it in any of those 2 cells. So we know that 9 would never appear here, and it will never appear here anyway. So using this 9, we can't have 9 here, we can't have it here. So the available cells are those. Well, that's 3 positions. That's not so interesting, not so impressive. Now let's look at this 6 and this 6, and we can do the exact same logic as with 9s here, meaning that 6 can't be in any of those cells, it can't be in any of those, it can't be in any of those by Sudoku, so 6 has to appear here. And then there's a 6 somewhere there. But placing 6 here would need that 6 appear somewhere here, but you see that the 6 that are already here prevent that from happening. So this could never be a 6. And 6 here would put a 6 here, but then we wouldn't be able to place 6 in any of those cells. So this is not possible either. And there's a 6 here. And I was about to say we now know that 6 can't appear here, but that's not true. 6 can still be somewhere around here. Actually, the forbidden cells for 6 are here and there. So there's a 6 here or there. And that doesn't seem to be that useful. Let's have a look at 6 in this box. So by Sudoku we can remove that, this and that. And we know that 6 can't be here because then it would have to appear somewhere here. So the forbidden cells are those. But there are still 3 options. Well, I just put corner pencil marks, not sure that's really useful. So now about this region, so 6 can't be here by Sudoku, so there has to be a 6 somewhere here, that's it. But 6 can't be here, or it would have to be somewhere here, so 6 is in one of those 2 cells, and now we can remove this option and this option, and put a 6 here, which removes this option, and places a 6 here, which removes both options here. So 6 is here, can't be here, it's here. Right. So now, those 2 digits, what are they? At this point, I can't say. But there's the question of what are those digits? And we know that both digits here must appear somewhere here. So this digit can't appear here, so it must appear somewhere here, and this digit is not 6, so it has to be a 7. And this digit here is somewhere in those 2 cells. And let's ponder what it can be. This digit can't be 1, it can't be 2, can't be 6, 7, 8, can't be 5, 9, so it can only be 3 or 4. So there's a 3 or 4, and actually the available values here are 1, 3, 4, and 8. But that's not usual, that can't be 3. That's quite unusual for me to pencil mark 4 values, but that seems right to do so. And this digit here that appears somewhere here will have to appear somewhere here as well. So 2 is somewhere here, and now there's something similar here. This digit must appear somewhere here, and it can't be 2. So this digit is the other digit here. Let's ponder, what can it be? It can't be 1, 5, 6, 9, it can't be 2, it can't be 3. So I think this is 4 or 8. Let me check. 1, 2, 3. Oh, no, it can't be 7 because of those 7s. So there can't be a 7 in here. Actually, by Sudoku, there's a 7 here. So this digit that appears somewhere here is a 4 or an 8. So the options here are 2, 4, and 8. And there has to be a 3 up there. And this digit here has to appear somewhere here. It can't be 6, so it's 1. Let's ponder what goes in here. It's not 6, so the 2 digits here are among those. And you see that this digit is different from both digits here, so this has to be the same as this. And it can't be 1, so this is not 1. This is 4 or 8. And that creates a 4-8 pair in this column. The remaining 3 digits are 3, 5, and 7. But this can't be a 3. And we know that 5 doesn't appear here, so this will have to be a 7. This is the same digit as this. And this is the same as one of those digits. We don't know which one yet. Where should I look now? Oh, something interesting here is that there's a 4 somewhere here, But if this were a 4, then it would have to appear here as well, and we couldn't place a 4 in this anymore. So this is actually an 8. We can remove 4 from those cells. The option 2 is not valid either. And then this digit can't be 1, can't be 2, can't be 6. So this digit is this one, so it's 8. That's 2, that's 8. So we know that this is 4, this is 4. And this can't, yes, it can be 1. If this 4 goes there, then this can still be a 1. And it can still be a 3, actually. There must be a 2 in these columns. It's here. And this must be 1 or 3. But it's a digit that has to appear here, so it's a 1. So that's a 3. And now 3 and 4 are both still valid for this cell. Those are 3, 4, or 5. And here we need 1, 5, and 8. So this is 5. Those are 1 and 8. This 5 now makes this a 3. This a 5. So this is not 5. This is 5. Up there we get a 3, 5, 3, 4 pair. And the leftmost part of the grid is now almost full. So let's move on to the right. This row still needs 1, 5, and 8. And this row still needs 1, 2, 5, and 8. And the interesting part is that this has to appear somewhere here, and this has to appear somewhere here, to be more precise. So this can't be a 2. So this digit 1 or 5 must appear somewhere here. And we need a 2 somewhere. We also need a 4 somewhere down there. And 7 can't be here, so 7 also has to appear down there. That's a 4, 7 pair. And these are 1, 2, and 8. But this one is not 8. And this row still needs 3, 5, 7, and 9. So this is 5 or 7, but 7 doesn't appear here, so 7 can't be in this cell. 7 can't be here, so this is 3 or 9. But we already proved that this can't be a 9, and because a 9 here would have to be there, which is impossible, so this is 3. That's not 3. That's 7 or 9, and this is also 7 or 9. This digit here, not sure there's something to do with it. The options here are 1, 3, and 7. And there has to be an 8 somewhere here. What about this row? This row needs a 3, here or there. Here would be really fine with this 3. So 3, 5. There must be a 7 here, but 7 can't be in the shaded region. So 7 is here, that's a 3. So this is 9, and this is 7, and it puts the 9 somewhere. I don't remember where. So that's not 7, that's not 3. And actually, in this column, 7 has to be here. this is 103. So we can remove 1 from those cells. So there has to be a 1 here. That's interesting. Maybe I should dig a little deeper. So the digits here are 2, 5, and 8, but 8 is somewhere here. So this is 2 or 5. 2, 5, 8. But actually, no, not actually. Not saying what I was about to say. 3 can't be here. Oh, let's have a look at this. This is 4 and 5. There's a 5 here, so this is 4, this is 5. This 4 puts a 7 down there and a 4. And this digit has to appear somewhere there, so this digit is 5. It puts the 1, the 2, 8, and the 5. This 8 makes this 1, this 8. This is not 8, this is not 5. I think it's almost done. Here we need a 2 and a 4. But this is not 4, so that's a 2, that's a 4. Here we need 1 and 8. And we can see a 1, 8 pair in this column, so this can only be a 2. And 2 has to appear somewhere here, so it's here, that's a 5. Here, what do we need? 9 and 2, and because of this 2, 9 goes here, 2 goes there. So 9 is pushed into this cell. This has to be 1 or 4, but 4 doesn't appear here, so this is 1. 8 here, 1 there, 1 here. No, so 8, 1, 8. This must be a 4. And let's complete this. That seems to work. And it works. Fine. Well, I did much better than during the contest, but, well, I've already solved it, so I guess that explains the stuff. So, another magnificent puzzle by Siyuan Luo. I hope you enjoyed it, and see you soon on SudoKanard.